Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is Drawbacks of Rutherford model. In the previous lecture, we have studied whole theory of Rutherford model. Today we are going to discuss why this model got failed. The reason was that the Rutherford theory and the electromagnetic wave theory were contradictory to each other. So let's understand this point. So before starting the drawback of Rutherford model, let's discuss the electromagnetic wave theory first. So I'm writing electromagnetic wave theory. This theory states that when a charged particle accelerates, in magnetic field or when magnet accelerates in electric field. So what's my condition? The electromagnetic wave theory states that when a charged particle accelerates in magnetic field or when magnet is accelerated in the electric field, then that charged particle or magnet will emit a form of energy called electromagnetic waves, due to which the net energy of that particle or magnet decreases. So now let's talk about the electromagnetic waves. Electromagnetic waves comprises two waves traveling simultaneously. That is electric wave and magnetic wave. So electromagnetic waves comprises two waves traveling simultaneously, that is the electric wave and the magnetic wave. Now I am drawing the graph for the electromagnetic wave. Please understand it very carefully. That's my y-axis, that's my x-axis, and distance of or the direction of propagation, or direction of propagation. Now here what will happen? Let's firstly I'm drawing the magnetic wave. This is the magnetic wave traveling like this. Now I have named this wave to be the magnetic wave. Now let's talk about electric wave. Now the electric wave will be perpendicular to the magnetic wave. So that's my electric wave. I'm writing, this is my electric wave. So the magnetic wave will travel in the y plane and electric wave will travel in the x plane. So what you can observe over here? You can observe that first of all, the magnetic wave and electric wave are perpendicular to each other. Now, the magnetic wave is perpendicular to the direction of propagation, and you can also see that even electric wave is also perpendicular to the direction of propagation. That is my electromagnetic wave. So I'm writing in electromagnetic wave the electric and magnetic wave are perpendicular to each other, are perpendicular to each other and also perpendicular to the direction of propagation of wave. Please try to imagine this diagram in 3 dimensions. You can see that the magnetic wave will be in the y plane and the electric wave is in the x plane. Now you can easily observe that magnetic wave and electric wave are perpendicular to each other and also perpendicular to the direction of propagation. So that was my electromagnetic wave theory. It says that when a charged particle accelerates in magnetic field or when magnet is accelerated in the electric field, then that particle, the charged particle or the magnet, will emit a form of energy called electromagnetic waves, due to which the net energy of that charged particle or magnet decreases. Now I have shown you the what is the electromagnetic wave through a diagram. Now let's apply this electromagnetic wave theory on the Rutherford theory. Now let's talk about the atom. I'm writing in an atom. Rutherford states that electron revolves around the nucleus. Now what is electron? In an atom, the electron. What is electron? It's a charged particle. The electron revolves around the nucleus in a nuclear field. So, in an atom, the electron, the charged particle, revolves around the nucleus. In a nuclear field, you can easily observe that now charged particle is revolving in the nuclear or a magnetic field of the nucleus. So, the electron, due to which electron will emit electromagnetic waves at every point of revolution. So the electron will emit electromagnetic waves at every point of revolution, because electron, being the charged particle, is revolving in the nuclear field of the nucleus, and that field is attractive because nucleus is positive and electron is negative. So the electron will emit electromagnetic waves at every point of revolutions. So the net energy of electron decreases. Net energy of electron decreases and gets attracted by nucleus by stronger forces. So electron will follow the spiral path, and will finally collapse on the nucleus. Let me make a diagram for you for this thing. My dear students, that is my nucleus. This is my orbit. That electron is present over here. Now, electron will emit electromagnetic wave at every point of revolution, due to which it will feel more attractive forces by the nucleus and will follow the spiral path and will finally get collapsed on the nucleus. Now, at each and every point, the electron was emitting electromagnetic waves. Let me show you like this way. The electromagnetic wave emitted, electromagnetic wave. I'm just showing the few points where electromagnetic waves will be emitted. These waves will be emitted by this way. So electron is finally following the spiral path and will finally collapse on the nucleus. So that was my EM waves. So it signifies that at every point of revolution, the electron has emitted electromagnetic waves and will finally, the net energy of electron will decrease, due to which it will feel the stronger attractive forces by the nucleus and will follow a spiral path and will finally get collapsed on the nucleus. So, but in reality, but in reality, I'm marking, but in reality, nothing happens like this. Nothing happens like this. A big cross. Nothing happens like this. Nothing happens like this. Means electron revolves around nucleus, without being collapsed on it. Without being collapsed on it means the whole atom is stable. Means whole atom is stable. According to the electromagnetic wave theory, the electron is accelerating in the attractive field, magnetic field, or the like nuclear field of the nucleus. So electron will emit the electromagnetic waves at every point of revolution and will finally follow the spiral path to collapse on the nucleus. But in reality, nothing happens like this. Means electrons revolves around the nucleus without being collapsed on it. So atom is stable. So here at this point, Rutherford, so I'm writing the main drawback. Now is the point of drawback that Rutherford was not able to explain stability of atom. Stability of atom. Nothing happens like this. And Rutherford was not able to give reason why nothing happens like this. That means Rutherford was not able to explain the stability of the atom. That was the drawback of the Rutherford model, which was further carried by. This topic was further carried by our next scientist called Niels Bohr. So in the next lectures, we are going to study the Bohr atomic model. So today we have completed the Rutherford atomic model. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.